What we're going to talk about today on this lesson are frequency distributions and their graphs. To summarize quantitative data, we use what's called a frequency distribution. Just like those for qualitative data. However, since these data have no natural categories, we divide the data into what's called classes. Classes are intervals of equal width that cover all values that are observed in the data set. And what the lower class limit is of a class is the smallest value that can appear in the class, and the upper class limit of a class is the largest value that can appear in the class. The class width is the difference between consecutive lower class limits. And if you look at this data set and you look at the frequency chart, my first class has a lower class limit of 0 and an upper class limit of 4. It goes from 0 to 4. And I have 2 items that fit in that class. My next class is from 5 to 9, and I've got 1, 2, 3, 4, and so forth. So that's how they come up with it. The class width, you subtract your lower class limits. So 5 minus 0 is 5, or 10 minus 5 is 5, whichever you wanted to do. 15 minus 10 is 5. Now, that's how Alex is going to do the classes and the frequency. But another way that you want to be able to think about it is like this. Instead of saying 0 to 4, I'm going to use the lower class limits. And I'm going to say, okay, 0 to less than 5. Okay, because 4 is the first integer that's less than 5. This data is all integers. That's the same thing. The next class, instead of 5 to 9, it would be 5 to less than 10. The next class would be 10 to less than 15. And the last class would be 15, not less than 19, because that doesn't make sense. 15 to 19 or 15 to less than 20. And you'll see why that's important in a minute when we do our histograms. Now, when you choose classes, every observation has to fall into a class. Nothing can be left out. The classes can't overlap. Like if it was the digit 4, you have to know where 4 goes. 4 can't go in 2 places. The classes must be of equal width, and there must be no gaps between classes. Even if there's no observations in a class, it must be included in the frequency distribution. Now, on this one, when you look at this data, and this has a lot of data, it's 65 pieces of data. It's emissions for 65 vehicles in units of grams of particles per gallon of fuel. And it says construct a frequency distribution using a class width of 1 starting at 0.00. Now notice that this data is 2 decimal places, hundredths. That's why the classes are going to look like that. So I'm starting at 0.00. Now what you want to do first is focus just on the lower classes. So it says my class width is 1, so I'm going to add 1. 1.00. And I'm going to add 1 again. And I'm going to keep going. And when you look at your data, I see a 6.55. That might not fit in my data, but I'm not going to worry about that right now. I'm going to get my upper classes and see. And here's how you're going to get your upper class. Now, the first class goes from 0 to less than 1. Okay, 0 to less than 1. In decimals, the first decimal to the hundredths place that's less than 1 is 0.99. If it was tenths, it would be 0.9. If it was integers, you know how the 5 went to the 4. Okay, so you go with whatever your data looks like. 1 to less than 2 is going to go to 1.99. 2 to less than 3, 2.99, 3.99, 4.99, and so forth. And when I get to this one, I look at that 6.55 and I see that that's no problem. Now I'm going to count the first one, And then I want you to pause the video and count all of them. Okay, but here's the first class. It's from 0 to 0.99. So I'm going to go through and count them. When I count them, I count by the columns. And I came up with 9. Pause the video and count the rest of the frequencies. The rest of the frequencies would be 26, 11, 13, 3, 1, and 2. And here's how I check myself on this. I add these up. If you get, there were 65 vehicles. If you get 65, that's a good chance that you're right, but it doesn't 100% mean you're right. So be careful counting. And sometimes we want to talk about relative frequency. And what we do for that is we do the frequency divided by the sum of all frequencies. When you're doing the relative frequencies, you want to set these up as fractions. 9 over 65, 26 over 65, and so forth. And when you get your decimals, we're going to do 4 decimal places. I'm going to do 9 over 65. And when I do the 4 decimal places, I'm going to do 0.138. That 4 is going to go up because there's a 6 beside it. If there's a 5 or more beside it, it's going to go up. My next one is 26 over 65. You can either put that as 0.4 and all the zeros if you want, or just 0.4. If you want to put all of the zeros to make it match, that's fine too, to make it have the 4 decimals. 11 over 65 is 0.16. 0.1692. 13 over 65 is 0.2000. 3 over 65 is 0.046. That one you want to take up to a 2. 1 over 65 is 0.0154. And the last one, 2 over 65, is 0.030. That 7 needs to go up to an 8. Now, when you're doing a histogram, once a frequency distribution or relative frequency distribution has been created, the information can be put in graphical form by constructing a histogram. And what a histogram is, it looks like a bar graph, except it's quantitative data. So it's going to have classes and numbers, and the bars are going to touch. So notice that the bars all touch. And what I want to do is do a frequency and a relative frequency histogram. And if you notice you've got a lot of space, I'm going to do the frequency histogram here. I'm going to label it as frequency histogram just so you'll know which one we did. And I'm going to do the relative one down here. And you want to make it about the same size if possible. And you'll see why at the end. So going back to frequency, I need to go up to 26. And the way you're going to number your classes, this is going to look a little bit different on Alex. It looks a little different done on the computer versus by hand. The way we're going to number our classes, I want you to number them by the lower classes. So I'm going to number 0 through 6. And I need to go up to 26. So I'm going to go, I don't like to start my 0 right by the axis. That doesn't matter. I'm going to go like right here. 0, 1, 2, 3, 4, 5, 6. You always want to label your axes. I'm going to label my axes as emissions. And I said for the frequency, we needed to go up to 26. So I'm going to number by fives. And you can call this counts or frequency or number of cars. I'm going to go 5, 10, 15, 20, 25, 30. All right, and the first one, if you look back at your classes, I'm going to look on my paper instead of scrolling back. But if you look at 0 to 0.99 or 0 to less than 1, you have a frequency of 9. So I'm going to go up to 9 like that and put my, my bar. The next class is 1 to 1.99. I'm going to think of it as 1 to less than 2, and it has a frequency of 26. You've already got part of the one side of the bar, so do it. I'm going to do it in red so you can see it. Go like that. All right, and that's going to be 26. The next one is 2 to less than 3, which is going to be 11. I'm going to use a different color again so you can just see what I do. And notice how everything's together, and look at how the x-axis is numbered. 3 to less than 4 is 13. 4 to less than 5 is 3. 5 to less than 6 is 1. And that last class is 6 to 6.99 or 6 to less than 7. So I'm going to go here and put a 7, and it is 2. So something like that. And questions that Alex will ask you about, it will say, what number of cars had between 1 and less than 2 emissions? You would say 26. Or what number of cars had less than 3? You would add 11, 26, 9. Where would 4 be? And 4 would be counted here. Okay, so 4 is counted there. That 13 is 3 to less than 4. When I do the relative frequency, I'm going to do the emissions the same way we did up there. So I'm going to go 0, 1, 2, 3, 4, 5, 6, 7. And this is emissions. And anytime you're doing relative frequency, you're doing the decimals. Anytime I do decimals, I'm going to count by tenths. And when I look at this one, I need to get up to 4.4. So I'm going to go 0.1, 0.2, 0.3, 0.4. Now, if you don't want to count it by tenths, you can go in after you've done that and add your zeros. You can add as many as you want. You could add the 4 decimal places if you wanted. I'm going to add here, this is 0.05, this is 0.15, 0.25, and 0.35, just to help me. The first one has a frequency of 0.1385, so like about 0.14. So 0.1385 is going to go to right there. The second one from 1 to less than 2 is going to have a frequency of 0.4. Two to less than 3. 2 to less than 3 is about 0.17, 0.1692. Three to less than 4 is going to be 0.2. And you see how each time I'm putting them, you're using that back from the one before. 4 to less than 5 is going to be about 0.05, 0.0462. 5 to less than 6 is going to be about 0.2, 0.0154. And the last one is going to be about 0.03, 0.0308. Something like that. And if you look at these two, if my scales had been better, they would have looked identical. If you look at these two, for the first time we can talk about that, we can say they look the same, but not only do they look the same, but they have the same shape. When you're talking about qualitative bar graphs, you can't talk about shape because nothing says you have to start with blue eyes. You could start with brown eyes. When you're doing quantitative, you have to start at 0 or wherever your number starts. So you can say that it has the same shape. And that's how we graph a histogram. Now, when you choose the number of classes, there's no set rule for the number of classes. What you're going to do with this, when you're doing the number of classes, they can affect the shape. And when you have too few classes produce a histogram that's lacking in detail. Too many produce a histogram with too much detail. Like this is the same histogram that we just did. This one, I like what we did better. This one has too many. This one has too few. And in general, you use at least 5. An open-ended class is one where sometimes it's necessary for the first class to have no lower limit or the last class to have no upper limit. Such a class is called open-ended. And it's perfectly fine to do this. If you look at this frequency diagram, they're talking about pneumonia deaths. And this is open-ended because that last class is 85 and older. So it's open-ended. Perfectly fine. But if it's open-ended, you cannot do a histogram. Now, I don't want you to do this on your paper, but I want you to look at mine and just pretend that this was not here. All right, if that was not here, here's what I would know. I could do a histogram, and here's what I would know. It has 1, 2, 3, 4, 5, 6, 7, 8 classes. You count the classes like that. And the class width would be, you subtract your lower class limits. It would be 15 minus 5 is 10. Or 25 minus 15 is 10. 35 minus 25 is 10, etc. That's how you would do the widths. Now, we don't do a lot like this, but if data are discrete, we can construct a frequency distribution in which each possible value of the variable forms a class. The following table and histogram presents the results of a hypothetical survey in which 1,000 adult women were asked how many children they had. And when you look at this, when you're doing this one, this 0, it's, like I said, it's countable, it's discrete. This 0 is the class. If it was something like that, that makes more sense than saying I have between 0 and less than 1 children. That wouldn't make any sense. Now, a histogram gives the shape of a data set. Statisticians have developed terminology to describe some of the commonly observed shapes. A histogram is skewed if one side or tail is longer than the other. A histogram with a long right tail is said to be skewed right. And here's how I can tell which way the tail's going. Think of this as a dinosaur tail, and here is the tail. It's going off to the right. Okay, it's positively skewed or skewed right. A histogram with a long left tail is said to be skewed left. And if you look at this one, it's skewed to the left. The tail goes to the left, negatively skewed. A histogram is symmetric if its right half is a mirror, I'm going to put it in quotes, of the left half. Very few histograms are perfectly symmetric, but many are approximately symmetric. So like if you look at this green one, it looks like it has a right tail and a left tail. All right, so it's not skewed when you're looking at it. It's approximately symmetric, and a symmetric histogram with a peak in the middle is said to be bell-shaped. And a symmetric histogram in which all classes have approximately equal frequencies is said to be uniform. An example of this would be, I live in a small town. Most of our grades have the same number of students. If those numbers match that, that would be an example of a uniform histogram. A peak or a high point of a histogram is referred to as the mode. A histogram is unimodal if it has only one mode, and bimodal if it has two clearly distinct modes. So when you look at this first one, technically this is the mode. Okay, so when you look at that, that's the mode. However, what they think of is this whole thing is the mode because that's where it peaks. It peaks in the middle. When you look at the second one, technically the one I have the arrow drawn to is the mode, but it has two peaks in the graph. So it peaks and then it goes down and then it goes back up and it peaks again. That's why it's bimodal. What I want you to do is cut the video off and do both check your understandings. All right, the first one, when you're looking at this, check your understanding, the first one is going to be skewed to the right. When you're talking about the shape, you don't have to talk about the bimodal and unimodal and all that. You want to talk about the skewness. When you look at the second one, it is skewed left. When you look at the blue one, it is uniform. And when you look at the green one, it is like that one, it is bell-shaped. This one says, is it uni or bimodal? This one is uni. It's got a peak in the middle. The green one is unimodal. And the red one, even though this is technically the mode, it peaks here and it peaks here. This one is bimodal. And that's it for our lesson on histogram.